Bore da pawb, croeso I CBAC, Dylunio Technoleg. Morning everyone, welcome to this WJEC GCSE D&T seminar. Okay, the focus obviously today is on the NEA. So, slightly different from the current controlled assessment that we had with the legacy spec. We've got a non-examined assessment. One of the drivers is obviously the process of iteration. So there will need to be evidence of how the students are going on their design journey and how this process of think, test, analyze and rethink occurs throughout the design development stages. Okay, so that's one of the drivers. We're going to look at some strategies later on where your students can demonstrate the iterative processes using a range of different tacts and an overview of the NEA. So this graphic obviously shows the iterative idea where they tackle a context, they identify a number of different possibilities for design scenarios, and then once they focus on the scenario they're going to tackle, we want this process of think. I come up with ideas, model and test those ideas, analyze and reflect, and then that cyclic approach, continuing to do that until their design idea evolves to a stage where it's a final idea, and then it's ready for production. Okay, so that's the model that we're after, and that's the evidence that we want to see from the students. So understanding the context, what we're after here is the students coming up with a demonstration of understanding of all the problems they identify based on whatever the context is. So it could be sport, it could be well-being, it could be fitness, it could be health, whatever it is. If they're camping, if they're walkers, if they play sports, whatever the scenario is, they will identify a range of different problems that occur within that particular interest that they've got. They need to know what happens, they need to know when, they need to know why the problems occur. So the relevant and focus is research. It's relevant, focused. They identify the information that is pertinent to this problem. So we want to get away from the meaningless research that they sometimes tend to do, and we want the research to be focused. Okay. So what's the result of the problem? One of the most important parts of this spec is the reference to the needs and wants of the users. Okay. Through every part of this NEA, the users' needs, wants and values are referred to in the marking criteria. So for those students to access the top marks, they are going to need to have to identify at this early stage the problem that the user has and the needs and wants that they have to solve that particular problem. And throughout the design and development stages, they should be exposing their thinking, their ideas, their models and so on to the users, okay? And getting feedback and analysing and evaluating that feedback and making it part of the iteration process, okay? What we sometimes see is that the users are focused on at the start of a project, and then they get the users to evaluate the product at the end, and they've missed it out completely in the middle. Okay, the users haven't been involved in the process during the design and the development stages, and they should be. Okay, so any modeling, any prototyping, any ideas should be shown and discussed with the client, the target market, the user, and feedback from that should be included in the design and development throughout the iteration stages. Okay, so that's a bit of a different one for this year. What needs to be prevented? Empathizing with the user, trying to put yourself in the position of the user and experience the problems that those users experience. Some of the students will be designing these products for other people, could be with disabilities, could be elderly, could be children with learning difficulties or whatever it is, so they're not going to understand the problem from the user's perspective. So trying to empathize and understand what the problem is could be an important key, okay? And that, again, that's a design strategy they could use. Observing the problems and then obviously presenting the possible design problems. You will notice when you look at the marking criteria that they do need to identify a number of possible projects that they could tackle, not just one, okay? So there needs to be a range. Once they've produced that range then, we want to focus on one project, okay? So that's where we want the depth to come from. So we've started off with a very broad range, a broad spectrum of possible ideas, and then we want to focus down now into one problem and go into that depth of understanding what that problem is and understanding the needs and wants of the target market. So do I understand the problem? Record thinking, sketching, and generate quick ideas, generate some initial early thoughts. We want these to be untidy, we want these to be messy, we want these to be quick. All the ideas that come into the students' minds, we want those recorded quickly, okay? So we're not expecting to see, you know, amazingly good drawings that are fully annotated and fully detailed here. We don't want that. We don't expect to see that. These are going to be thumbnail sketches, quick developmental pencil sketches, okay? There could be some brainstorming going on, obviously looking for influence, looking for help, discussing problems with the users, looking at existing products. Why don't these existing products fully solve the problem that's occurring? What don't they do? What do they do well, but what's missing? You know, where are the gaps for the students to build in into their design project? Disassembling products is a good strategy to do here. You know, if the students look at existing products, they can start to take those apart, do a bit of reverse engineering. That's another design strategy. And they will take a lot of information from taking another product apart, because they'll see how that was designed and manufactured and the materials and components and so on that's involved in that product. Looking at other designers' work could be an opportunity to pick up on the style of a particular design or designer, pick up on some features that a particular designer uses, you know, or maybe even outside the designers, look at biomimicry, look at biomorphic analysis, look at morphological analysis, look at buildings, architecture, and build in some style, maybe, you know, cultural shapes, forms, etc. from other sources. A who, what, when, where, why, how can also help. That might trigger them to push them forward. So there's another strategy for the students. And ideally then to come up with a basic outline of a brief and a spec to move forward with, okay? So we move on then to the ideas stage. So here we want, what ideas do I have? Let's explore those with some sketching. So it might be a revisiting of the initial ideas that they came up with first, and then a bit more of a focus, going into a bit more depth. What are my ideas? What do they look like? How would they work? How would they be manufactured? How does the user interact with them? How do they function? What sort of materials would I use, and so on? And obviously when they start developing these ideas, this sketchiness, it's quick, it's busy, and it's going to lead on to needing to do some testing, okay? The requirement to do some modeling and prototyping to see whether these ideas will actually work in practice, because all the work is being done, obviously, in theory, on pieces of paper, 2D, okay? So, will my ideas work? What will need to be changed or modified or improved? How do I make my ideas better? Do they meet the needs and wants of the users? So again, it might be an opportunity to involve the users here to get some feedback on how your ideas are forming at this particular moment, and using the users to steer you towards, you know, the next idea, the next iteration. Looking for influence and help again then, exposing the ideas to the client, some simulation modeling, some CAD possibly, some empathizing, you know, experiencing the problem and so on. And I think then you're probably ready to do some testing. So let's try some ideas out, which takes us to the testing section. So introducing CAD modeling maybe, testing ideas, what are the results, more detailed sketching and more analytic thinking here. You know, you're looking at, do these ideas actually function? And if not, why not? And what needs to be improved? And then improve it. So this is the stage where this iterative process is started to trigger and go cyclic. So CAD modeling, maybe size, form, shape, aesthetic detailing. Will the ideas actually work in terms of the function? Changing, modifying or improving ideas will occur. Again, do these meet the needs and wants of the target market? If yes, great. If no, okay, what do we need to do to change that? What do we need to do to improve that? And a demonstration of how the idea is growing and refining and developing as it moves forward. Okay, onto the analysing and reflecting. This is a critical part because this part sometimes gets missed out by students. You know, they produce a range of ideas and they pick one idea and they say, that's my best idea, so that's my final idea. That's not really true, is it? Initial ideas might be all having their merits and failings. So do you take some good features from all your ideas and morph them together into one new idea? Or is it one idea that's developing and being refined along the way? But we do want to see this idea of the development being analysed and evaluated, okay? How far do my ideas meet the spec? Where are the gaps? what do the users think? What do they say? Let's get some feedback. What are the responses from the target market? Identify areas for further work. What needs to be refined? What are the changes need to be made? What other things do we need to introduce to get this idea to be better? Again, looking for influence, and then this thing of reiterate. The process is a cycle, so again, we rotate around and around and around, okay, in order to get that process running. You may need to amend or refine your ideas. You may need also to go back to the brief and the spec at this point, because the brief and the spec may need to alter. You may need to add bits to the spec, or you may need to remove bits from the spec. So we want the spec to be a working document as well. I think a lot of students produce a brief and a spec, and then they park it in the folder, and then they use it at the end when they evaluate the product. We want the spec to be a working document that they work through during the design and development, so they are constantly jumping back to the spec and using it as a checklist to drive the designing, okay? So providing the spec is rigorous and detailed and robust, that's going to help the students to design. So it gives them a clear framework of what needs to be included. So we want to see that being used more effectively if we can. Okay, so we then got a sleep repeat type pattern where we've got no real starting point, no real end point. The previous spec would start with analysis, and then they produce a brief and a spec, and then they'd move forward with the design process. With this spec, they can start with an existing product. They can start by evaluating an existing product. They can start by talking to the users. They can start by sketching. They can start by doing some 3D printing. They can start by doing some CAD. There is no definitive starting point, okay? So students will have to take ownership of this process, this project, and they will complete the project as they see fit. So there's no 30-page workbook, there's no timed sessions, there's no set way of submitting this project in a folio or a sketchbook. Students will do it as they see fit, okay? Which suits their needs, suits their abilities, their skills, and demonstrates how this problem has been identified, designed, developed, and solved, okay? So there's no set pattern for that. Picking up and dropping off at any point. Designing can be shelved or revisited in an unlimited way whenever they see fit. The process is cyclic and not linear, okay? That's the key, isn't it? And it's this idea of think, test, evaluate that we're after. And that's constant throughout this process. Okay. Obviously, when they get to the end of the cyclic process and they've reiterated this design and they've got it to a stage where they think it's perfect, it's ready for production. So we're after a fully functioning pre-production prototype. That's what we're after. They plan the stages of production, the sequences of how they're going to make the product. Then they construct the product, and we want it to be a high-quality, fully functioning product as well. We want a fully developed final solution that fully meets the spec and definitely meets the needs and wants and values of the target market, of the users, okay? So no stone is left unturned with that one. We want it to be a clearly detailed solution and no sort of evolving as the making process happens, which sometimes can happen in schools with students. They've got an idea, they start making it, and then the idea changes day on day on day because they haven't really designed it thoroughly enough or fully enough, and they haven't really thought about the production of it. So we want to try and avoid that one. Deadline is met and a final user trial awaits. That's where we want to be by the end. Okay, Harry Beck's iconic London Underground map there from the 30s. We want our students to sort of think of D&T as a D&T Underground, okay? So they identify the need here, and on the end of the red line, they get to a final product or a launch. But there is any of those stops on that underground that could be used at any given time to do some designing. So when you talk about this NEA to your students, and if the students are currently in the middle of it now, I'd present them with this and talk to them about, well, what are you going to do today? Where are you going on the underground today? Are you going to talk to the users, user needs? Is it going to be marketability? Is it going to be existing products, designers? Is it going to be a creative thinking strategy? Are you going to do some modeling, some CAD? And all of those will play a part. And I say to my students in my centre, you're going to start at the identifying the need and you get to the product launch. You can go on any route, on any particular day, through any of those different stages and get to the final point. There's no one set way. You can avoid certain stops, you can take other stops. If one station is closed one day, you have to take an alternative route. So things crop up. It's a graphic, I think, that might help your students to understand the type of process that we're after. Okay, so maybe share that with those. Some examples of how this iterative process has been seen in schools. We've got some ideas here of a product design type project, which was a lighting project. There's the product. The student has done some sketching and designing, looked at precious stones, diamonds, and looked at snowflakes and things like that. And you can see the ideas coming through in the sketching. They've got the ideas and developed those a little bit, and then they've gone straight into some card modelling, working out how these ideas could form a 3D object and how they'll tessellate. So some card and some laser cutting and a bit of a glue gun being introduced there. And then into the CAD drawings to get the final designs perfected, and then there's your product. A nice, neat, fully functioning product there, which you can clearly see has come from a source, nature, snowflakes, diamonds possibly, and how they've tessellated those shapes to fit together. So some nice clever designing on that one. This one was a space-saving table for a primary school. So you can see the sketching and the designing, you can see the modelling and the thinking going on here, the introduction of CAD at the bottom, and there's your product. Multiple products stacked on top of each other using the A-frame legs to save space in a classroom in a primary school situation. So again, a nice idea. You can see the sketching process and how that design has developed and evolved into a final product. Similarly there with some lighting, this project was based on a Venetian blind where the student was looking at the light shade being able to be tilted to dim the lights, if you like, and not let so much light through. So the clever bit of this was this idea that the light shade would swivel, okay? So the students done a bit of designing, a bit of sketching. Again, we've got this introduction of CAD and an introduction of modelling and testing to see if this idea could function. And then we've got the final idea there where you can clearly see those slats that rotate, okay? So again, this student has found an idea, a spark somewhere, and then has brought that into their designing and done some testing and modelling to get that to function properly, and it's evident in the final outcome. So again, a little bit of clever thinking with this iterative process. Another one that's out on the display today in the GCSE section, GCSE textiles project, laser cut dress. Very, very clever way of using laser cutting with a challenging fabric as an overgarment to a textiles problem. The light then on the right hand side, that's innovative because it's magnetic and it can be removed from the stand and used as a torch, as is shown in the bottom photograph there. So it's not just a traditional product, there's a little bit more thought that's gone into that. It's a portable torch as well as a study lamp, sort of desk lamp, table lamp. This one just looks like an RMT job on the bench. However, when you open it up, there's multiple storage boxes that solve particular storage problems. So, for a GCSE kid to get that, to do that, and to get it all to fit together as well as that does, is pretty challenging and has taken a lot of thought. This one was an outdoor lighting brief from last year. This was a great product which was able to be portable, able to stand upright and flat on a table as a standard torch or lamp or light. It also featured an idea based on the 3-pin plug, okay, from a power supply, that allowed it to fit in a garden on a spike. So you could move this around in a garden, having a party, keep it on the drinks tray so you could use it to illuminate where you were walking, and also use it in the garden then to illuminate the path or whatever it would be where you were sitting. So another clever idea, which was a multi-function multi-purpose type design, which adapted to different situations, not just a passive standard sort of static product, which is a lot more creative. There it is, really good. Again, modelling and designing with textiles then, looking at fabrics, looking at construction methods, putting little bits of fabric on dummies, thinking how it would work. These are the sort of design strategies that we're trying to get the students involved in, get the students to think with. So obviously, it's not just during the NEA that the students need to do this. It's probably in lower school in Key Stage 3 where you're teaching the students these sort of techniques through mini projects maybe, so that by the time they get to GCSE stage, they've got those skills. They understand the process of iteration and they've encountered CAD and card modelling and prototyping and using these sorts of sketching techniques and so on. So, you know, they've got those skills in their toolbox already. It's not the first time that they try them at GCSE level. Some graphic type products, looking at identity, looking at packaging products, looking at travel and so on. Again, you know, multifunctioning products, tastefully designed using clever techniques, appropriate use of materials to produce an effective outcome. Okay, for your students, you can take them to those, talk to them about those design strategies that are on the screen there, and there's some links to YouTube videos there that the students might be interested in watching how those design strategies are used by designers. Okay, so I definitely show them those. Some short, quick videos that might be nice starters to lessons, or, you know, intervene during a lesson and talk to them about a different bit of modelling and might help them to think about how they can bring those skills into their designing. Okay, takes us on to the marking criteria for the NEA. Okay, so we talked a bit earlier about the user's needs and wants and this process of iteration, which are the two main drivers of this NEA. So we've got a very reduced number of criteria now. There's only 5. You can see that the iterative process is heavily weighted there with 30 marks. Okay, so yes, they do need to spend a lot of time identifying possible solutions, possible problems, possible projects, and that's worth 10 marks. Once they've narrowed it down and they've nailed down a brief and a spec, that's worth another 10, and then 3 times more marks then for the designing, all right, the iterative process of designing and development. The manufacturing of a prototype then, as we said earlier, we do still want high quality, fully functioning products, but that is only worth 30 marks, okay? So when you consider GCSE D&T now, and this NEA, which is worth half of the GCSE, manufacturing a prototype is really only worth 15% of a GCSE then, okay? So the emphasis of the new spec for GCSE is all on thinking, designing, developing this iterative process and meeting the needs and wants of the users, okay? It's not about making products, is it? Okay? The making of the product is a small part now. We still value it, it's still important, it's still critical, but you've got to make sure that the students are aware of how much effort and how much work they put into the other parts, because obviously 85% of the spec then is not about making, is it? Okay. And at the end there, then you've got the analysing and evaluating. So 2 sort of strands to that one. Analysing and evaluating design decisions as they occur throughout the process, and then obviously analysing and evaluating the final product against the users, which is a terminal exercise. It's done at the end. Okay. So 100 raw marks. So this one then, we want the design context to be analysed. There'll be a number of initial tasks. We want the research to be detailed and focused and relevant. We don't want wishy-washy, you know, endless, mindless sort of research being done that doesn't help the student. Focus it so that it's relevant and it's useful for them, so they understand the problem better. Okay. We do have to have this needs and wants of the users being considered, and we want existing products to be analysed. Possibly an opportunity here to research past and present designers. Okay. So there's the 9 to 10 marks. That's the top band. Okay. I've highlighted in red there the key words that need to be evident for the students to get those top marks. Okay, so you can see there we want comprehensive and effective research. It's got to be linked to the context, and where appropriate, past and present designers or products are being evaluated. The needs and wants of the users, look, dot E3, and then be able to produce a range of possible briefs, which is dot E4. Okay, so there's that broadness that we talked about at the start, evident in the 9 to 10 mark range. If they don't have that broad range and it's very narrow and it's not very focused, they can only get 1 to 2. So if they don't consider the user's needs and wants and it's all superficial and it's, you know, not very focused, there's no way they can get out of that lower band, which is a 1 to 2 mark. Okay. Next one, brief and spec. Very similar to what we do now. Specifications have improved over the last couple of years. They are being developed into being a bit more robust with more measurable criteria. Okay, so when your students are doing this, talk to them about, you know, not being vague and saying, well, you know, my product's got to be small, it's got to be bright and colourful, it's got to be safe, it's got to be comfortable for the user. They don't actually say anything. We want sizes, we want numerical values, we want weights. You know, if something's got to have rounded corners, what radius? What is the radius of the rounded corner? If something's got to be lightweight and portable, how heavy in grams or kilos? Yeah. So we want those criteria to be developed into fully measurable criteria, and that's really going to help the students when they're designing, because they've got clear guidelines what needs to be included in that product. Okay. So there's the brief and the spec. Yeah, clearly defined brief, a detailed spec generated which drives designing forward. Yeah, designing happens as a result of the spec being critically developed. That's what we're after. We want measurable criteria, and the spec is used throughout the process. I think that's the key. You know, the spec is a working document that should be referred to regularly. Tick bits off, cross bits out, add bits, take bits away, and so on. It shouldn't be just something that the students do and then leave until they evaluate at the end. That's not the idea. So for 9 to 10, a full range of problems are considered, good understanding of the task, a relevant final brief, and a detailed spec with measurable criteria to direct and inform designing and making. Okay, 9 to 10. There'll be examples up on the GCSE section today that would be worth 9 to 10 for this. So we're not asking for anything different than what we do now. So there's not much of a change with that one. Again, if there's only a single opportunity, you know, little Johnny knows he wants to design a fishing tackle box and that's what he wants to do, and you're not going to change that, then that's only one design task, isn't it? So they're going to be stuck in this 1 to 2 mark range, because they can't get out without having a range, without having more developed ideas. So, you know, you've got to share these marking criteria descriptors with the students and say, you know, if you don't do this, if you don't do that, you're going to have this mark. Yeah. And they've obviously then got to produce the evidence that there is a range of ideas, there is a detailed brief, there is a measurable criteria driven spec to gain those extra marks. Okay, ideas then, that's obviously 30% of the NEA. We want an iterative process, we want a range of strategies, and we've talked a lot about those strategies the students can use. Some students prefer CAD, some students prefer physical modelling, some students prefer card modelling. You know, let them decide what strategies are for them, but they've got to demonstrate the range to get those marks. Okay. Clear and detailed designing and testing, analysing against the spec, and using the users. Okay. At the moment in the controlled assessment that we've got upstairs exhibited, we've got 5 or 6 pages in the development, haven't we? Developing aesthetics, developing construction, developing materials and components, developing the function, and so on. It's the same sort of things we're after now, but your students have got the opportunity to develop the bits that they think are important. So if you've got a kid who's really hot on electronics, they can do all the development they want on the electronic side of things, the circuit, the PCB, the program, the PIC stuff, whatever it is. If you've got a very good graphics type student, then graphically they may want to do all the development. So it's maybe, you know, the appearance, the physical properties, the color, the shape, the form of the product, and not so much the control system. So I think this is good because the students can focus on their skills and their expertise, and you can steer them that way with this. So there's your 24 to 30 marks. So a big range here on this one, okay? 5 mark, 6 mark range there, 24 to 30. A range of strategies and techniques are evident in an iterative process. Fully developed ideas, effective use of modelling and testing, clearly relates to the spec, sophisticated skills. So we've got students that do this already, but maybe not quite in this way. So it's the way that they go about the designing that might have to change a bit, okay? Again, if they don't give you a range, and this is very limited and very narrow, then they're going to be in the 1 to 7 mark criteria, okay? So again, they have to show this range of skills. Making a prototype then, okay, yes, it is another 30% of this NEA, so it's still a big chunk of this project, this coursework. However, it is, in the great scheme of things, not that prominent when you consider that this is only worth half the GCSE, so it's only 15% ultimately. They want to produce a completed prototype to a schedule. They've got to show successful making skills and appreciation for quality and understanding of the equipment, tools, the manufacturing processes that they're going to use, that they're going to work with, okay? So we still want that high level of accuracy in the outcome, and we still want this product to function and meet the needs and wants of the user to solve the problem that they've identified, 24 to 30, again, another wide range of marks here. Comprehensive and relevant details of a sequence, appropriate materials, appropriate making skills, high quality product, excellent understanding of working properties and performance, and then selected tools and equipment appropriately and use them safely to produce an excellent outcome. Okay, nothing different to what we already have, and have good examples on display here today. If it's superficial or there's no details of a sequence and they've just made the product with the guidance of the teacher or the technician, then they're going to be in this 1 to 7 mark range, aren't they? So really, if they go through this in a very linear, narrow way, they're not going to score many marks. They're not going to accumulate many marks as they travel through. And lastly then, so as I said earlier, two different slots of evaluating and analysing with this. One of them is ongoing throughout the project, and one of them is final user trial based analysis at the end after production of the prototype. Okay, so we want them to appraise their concepts as they design and develop. We want critical analysis of the final prototype, and we want the opinions of the users. So it has to be tested in the environment it was designed for by the target market it was aimed at the end, and we want the evaluation of that, not a description. Okay, so avoid descriptive, I took it to the users and they used it and they all said they loved it. Well, yeah, okay, let's have a little bit more. So let's have a bit of depth. What do the users say? How does it answer the problem? Why does it work so well? Are there any areas for modifications, for improvement, for refinement? So that should be quite a detailed document there for that one. Okay, 16 to 20 marks there. Critical objective analysis, critical and objective testing, response to feedback, and identification of modifications. Yeah, that's what we're after for the top marks. If it's superficial and they just use their specification as a checklist and they tick, 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 yeah, my product does all of that, that's too thin. Okay, that's too basic. There's no analysis there. It's just a comparison exercise. They're only going to score in the 1 to 5 mark range there. Yeah, so they're the pitfalls really, okay, in terms of the marking criteria. This PowerPoint will be available on the website, on the WJEC website, so you can get a copy of that from there. Push the students, I think, with the strategies, because they are the things that the students need to demonstrate. Typical questions we get at this stage are, how many sheets do we need to produce? I think there's no answer to that. It depends on how well the student designs and develops. So you can't really put a number on it. Most students are going to do this through a sketchbook, okay? So it'll be an informal sketchbook where they design and develop the ideas as they move forward. There may well be a formal portfolio that the students submit with the brief and the spec and the final technical details, okay? And the story of the designing, the iteration, the testing, the modelling might be a different document like a sketchbook and a box of models and prototypes which show the journey that the student's been on the underground to get them to a final solution stage, okay? Students can use e-portfolios, students can use iPads and PowerPoints and things to show users and user interviews and opinions and so on. So don't think that everything has to be a paper-based documented evidence, okay? It can be, lots of interviews, it can be videos, it can be screenshots, screen dumps on a scroll. They don't have to print everything out. There can be supporting documents on a tablet or a laptop or whatever for the moderator to mark when they come to the centre, okay? Obviously, if the students are in year 10, they get these contexts started on June the 1st. So they identify a context on June the 1st in year 10, and they've got through year 10, through the summer, and all of year 11 to complete this NEA. And obviously they've got one chance to sit the exam, and that's the terminal end exam at the end of year 11. They don't sit the exam in year 10. So both of these assessments are done at the end of year 11 in the terminal year of the award. There's always a resit opportunity as well, so the students can resit the following year, okay, because there's no winter series exam, there's just a summer series exam.